Amazing. Hello, everybody. My name is Rahul, and I'm the founder of AI Hero. Some of you might know me from organizing MLOps events. Shout out to Jacob and Jimmy for having me. As fellow organizers of community events, I know how hard and how much effort it goes. Christy obviously had an amazing event space here as well. So I'm excited and thrilled to see you guys. This is a really good turnout. Here to talk about lessons learned fine-tuning Llama2 for autonomous agents. And let's jump right into it. Let's set some stage first, some background. We all know ChatGPT. We've seen some incredible changes happen since it came out in November of 2022. How many of y'all remember this architecture diagram from last year? Have seen this before? Okay, some of you have, right? So this architecture diagram is almost a year old now, which is fascinating. Time flies. So this one is an emerging LLM app stack from A16Z that happened around June 2023. Some of it is still relevant. A lot of it has changed. We've learned so much together. Around November, I was taking a break after having built out a Kubernetes foundational model training platform for 1,600 GPUs. I'm like, okay, glad that project was over. I was taking some break. And as you do, you do self-growth. I was learning how to do fine-tuning myself. And around the same time, we had this amazing wave of autonomous agents topic coming about. This was an article from BCG back in November of last year talking about how GPT was just the beginning and autonomous agents is the future, right? Lots of buzz around that time. So a little bit of background about me. I did my master's back in 2010. It's been a while. And I had been working for Toyota, through whom I worked a lot about agents. In fact, my first 2 weeks in the company Toyota ITC Labs was researching how Siri, which was then not yet an Apple product, it was an independent company, how would that work? And through that till 2017 is when I worked and researched on agents, particularly proactive agents. And I don't know if how many of you guys are aware of this word called kigakiku. It's a Japanese word which means attentive and proactively doing things that make sense and you're good about it. For example, if you see an elderly person coming in on the train, you will vacate your seat and you will give it to them. Something like that, right? This is not the exact word translation, but that's what Kigakiku is. And that brought me to like, okay, November 2023, all of this is happening. Let's look at what autonomous agents are. So just as level set, let's talk about what autonomous agents really means. Autonomous means acting independently, and it's able to do the job without you being in the room, right? So that's autonomous. Agent, we've seen so many agents in real life, you know, your insurance agent and so on and so forth. An agent is actually somebody you give credentials to and they do the job on your behalf, right? So you give them some privileges like, hey, it's okay, go and find the house for me. So that's your real estate agent, right? And so the third thing that I'll add to this is it's personalized, which is an autonomous agent, and this is the way I see it, which is an autonomous agent is not going and doing jobs for you ad hoc. It's not going to do something drastically different than what you want. It should do something that you prefer. And so that's the third angle for all of this stuff. One of the questions I had was, is chat the right user experience for autonomous agents? And so here, it's a multiple choice question. The moment I click this button, I run the question through a large language model, and it changes the state of a JSON dictionary. And this React app is hooked onto that JSON. And so the moment something changes from false to true, the React app changes the user interface. But there's no chat here, right? So what is the right way in which agents talk to you humans? That's kind of like where I was going with this. And that brings me to fine-tuning LLMs. That is why I decided to fine-tune LLMs. A little background about fine-tuning LLMs, if you haven't done this already. is last year we saw a lot of Colab notebooks doing QLoRA, like, hey, you can do fine tuning in a Jupyter notebook or a Colab notebook on a commercially available GPU. Who's done that last year? Great. So you're way ahead of the curve before, right? So it was really hot back then. The technique it used was called QLoRA, which essentially, we're not getting into the math behind training LLMs, but essentially on the left side, you see like what a full fine-tuned model looks like. So you have the base model, and then there are some layers that you're fine-tuning. Low rank adaptation means that you have some, you have fewer weights to train, and QLoRA is quantized, and it's doing one more optimization, which is it is doing paging in the memory to move data, to move model weights from the CPU to GPU, right? And so we've seen this last year a lot. And then everybody was asking this question like, hey, should I be fine-tuning Llama2? Should I be doing that? And so let's get that out of the way. When should you fine-tune, right? So first of all, fine-tuning LLMs is not meant to be a replacement for databases. Do it only when you have a long-term memory that you want to embed inside your model. Second, do it for a domain-specific vocabulary or tone in which you speak. So here's an example. You have a RAG typical instructions. What is monopsony? There'll be a retrieved context, in this case, a Wikipedia article, and your LLM will generate this answer, right? But let's say this is too wordy for you. You want your agent to seem smart and give a precise answer. So you'll go ahead and fine-tune a model to change the tone in which the agent speaks only to like one sentence answer, right? So here, the LLM is not looking up information. You've already given the context in, and the LLM's job is to look within the context for the answer and rephrase it, right? And that's all we're doing fine-tuning here for. And that works really well. Also, you should do fine-tuning. Think about fine-tuning if you have some task-specific structure of your output. For example, papers are written like abstract, introduction, prior art, step 1, step 2, and then conclusion, right? So think about that structure. Specific output schema, if you have a specific JSON schema to follow, SQL, YAML, or Pydantic classes. Context window with less prompting. So if you have a very thick prompt or a very fat prompt, things start getting slower. So you might consider fine-tuning then. And then smaller distilled task-specific models, which I think we heard the previous speakers talk about. And finally, please don't start fine-tuning if you have a handful of data. Do it when you have enough data. So that's that question out of the way. When should I be fine-tuning? But I'd like to encourage you to think about fine-tuning from a different perspective, not just the technology perspective, but why are you using fine-tuning? So there are 3 truths I learned about fine-tuning, and these are not mine. So these are other people's opinions, which I've kind of remixed into based on my learnings around it. The first one is LLMs are glorified autocompletes, but they're really, really good at picking the next word, right? So as an example, when Anthropic Claude first came out, you could click on edit mode and you could see what's happening under the hood. So when you chat with Claude, it lays it out as a script or a novel or a play dialogue between a human and an assistant, right? So you see human says, consider the following opening story. Squeaky was so-and-so. Please continue the story, ... And then assistant, ... And now the job of the LLM is to autocomplete it in the role of the assistant. But essentially, it is just autocompleting it, right? So a chat user interface, or a user experience, if you think about it, as human says this, assistant says this, human says this, assistant says this, human says this, assistant says what? That's a very simple framing of the LLM as an autocomplete, right? That's what's happening under the hood. Obviously, it's more complicated than that, but a mental model of what LLMs do. The second truth is that LLMs are just that, language models. They are not databases and not sources of real-time information. You cannot ask, now you can ask what is the time in Kuala Lumpur, but it is going to generate some code and run that code and get you the output, right? The LLM itself doesn't know what the time it is. And so what we're seeing is emerging techniques like larger prompts. This is just last week. We've seen some ability to upload files inside ChatGPT now. So that's where the context comes in, and it provides the data for the LLM. And the last truth here is all LLMs hallucinate, some better than others. Essentially, it's a game about how do you predict the next word correctly, right? And this one was an interesting 1-week drama that we saw last week, which was how many rocks should I eat? If you ask that to Google search, it would say, well, according to Berkeley geologists, at least eat 1 rock, right, per day, small rock. Don't make it big, just a small rock. But turns out that it was actually an Onion article, which is known to be a satirical newspaper in the US. It was an article, and it was just giving a search result. So it was not necessarily hallucinating, it just didn't get satire. The second photo here shows Mira Murat, I'm butchering the last name, Mira Murati. She's talking about what data did they use to train the Sora, and they just used all publicly available data and licensable data, right? And there's a meme there, which of the Reddit drama, but essentially, there's you know what kind of garbage exists on the internet, right? So it's all about good data and not large data. So when you think about all LLMs hallucinate, think about what data are you providing them. Awesome. So now we come to the meat of the talk, which is lessons learned. And this was originally a 1-hour talk that is condensed into a 30-minute talk. So it's going to be slightly fast-paced here on, but I hope you guys will follow up. So first is go beyond that that Google Colab notebook or Jupyter notebook, right? You've all seen that last year. It's great starting point. You'll understand the basics, and maybe you don't have to pay for a really large GPU, but go beyond that. There's a lot to be learned when you start actually training models at scale, or training models even on an EC2 instance or a simple instance which has a GPU attached to it. There's a lot to learn. For example, this is 2 loss curves. One here shows, from a data science standpoint, everybody's seen these loss curves. Loss goes down, model's learning well. Loss goes like this, model is not converging. You see that with LoRA. So when you use your LoRa Colab notebook, check out the loss. It's not going down, it's going up and down and so on. So you know that the model is not converging. Why use QLoRa? What you can actually do is train the model and then quantize it for inference, right? You can still do that. And here's an example of supervised fine-tuning, both with and without LoRa. So this is no QLoRa here. You can see that the blue line, which is the SFT plus supervised fine-tuning plus LoRa, is tracking really well the green line of the SFT for this data set of text to SQL, right? So you give it a text query, here's a predicted value, here's the actual value. You can see that they kind of look like SQL. So, it's kind of learning, right? So LoRa itself tracks really well if you do LoRa. QLoRa, not as much. Second lesson is that data science is much, much better than vibe check. I do that with prompts all the time. I change one word in the prompt and then I'm like, let's deploy to production, right? And you shouldn't do that, right? But what we want to see is we want a more data science way of doing things. And so as a data scientist, you guys know probably this really good loss curve, which is you have 2 splits of your data at least. If not 3, it is a training split and a validation split. If both are going down, that's great. The moment the validation starts going up, you're overfitting your model. Stop here, right? So we all know this. And so when I trained the model, Llama2 for one of these use cases, you could see that the learning goes down on the training data set. But after a certain point, the validation split, the loss starts going high. And in fact, this is another reason why I don't like QLoRa. Again, if you really want to start learning, QLoRa is a great place to start. But when you're training models for production, I wouldn't recommend that. So here you can see that QLoRa, the loss, both training and validation, starts increasing. With LoRa, the loss is kind of going down, but it's plateaued a bit. Luckily, the evaluation loss, the validation split loss is tracking the loss. SFT learns really, really well, but then it's overfitting, right? So That's one difference between LoRa and SFT. LoRa learns better. Well, it doesn't learn as well enough as SFT, but it also doesn't forget as much. The third one is don't chase the herd. And what do I mean by herd? Well, we've seen all these animal name models. So one time I was like, hey, what do I do next? And somebody's like, oh, do you want to try the next? Do you want to try Orca? Do you want to try some other model, right? And that's not the right way to think about it. Obviously, they've made some improvements, but the way you need to think about it is framing the task right. Is your task for fine-tuning framed the correct way? And then when you realize like, hey, based on the literature, this doesn't work anymore, then you upgrade to a different model. Always be improving your data. So here's an example where I was fine-tuning a model. The loss curves look beautiful, don't they? The validation loss is tracking training loss. At a certain point, there's a jump because the epoch changes. And then you're like, okay, they're diverging now. Let's stop somewhere around here, right? But then the solution here is not necessarily change the model. The solution here could be get better data so that you can still go lower at your loss, go lower than 0.9 or whatever it is. Squeeze that GPU juice. You have tools that let you see how much GPU you are utilizing. So if you're lucky enough to fit your model inside one GPU and don't get into out of memory error, you can see how much memory has been allocated. Keep some buffer just in case for validation, but then you can start increasing your batch size. Right? Instead of trying to fit bigger models, try increasing your batch size. That'll save you time and at least learn faster, right? So look at the data to figure out how you can improve your GPUs. Choosing a framework that helps you iterate fast. This is important. In data science, you don't want to wait while the paint dries. You want to keep iterating fast. So use a framework, and there are plenty of these out there, that help you experiment really fast, see those loss curves, immediately detect like, hey, this is not actually improving your model. Let's switch out, right? So choose a framework that works better for you. My main competency is in MLOps and LLMOps. So I built one myself on Kubernetes. The way it works is you have a launch.py script. So my friend and I built this out. We open sourced it. It was gathering dust for a few months now, so I need to upgrade it, which is why I'm not providing the open source link here. But essentially, when you create a launch py, it'll create a job on Kubernetes, it'll provide its secrets, and then it'll create these pods which will start training the model. They're fetching the base model from S3 or Hugging Face. They're fetching the data set. And then once the model is trained, they're sending it back to S3 or Hugging Face, whatever you choose. So this framework, along with observability, helped me move really fast. So do that. Pick any one that you want, right? Your LLM has quirks. So for example, if you've really trained models, you'll know that this is a start token. This is an XML kind of schema that we used for the first iteration of the autonomous agent, wherein it is answer the question, here's some data, and the actual answer or the prediction from the LLM was, can you change the value to the answer? So the answer is equal to 3, right? So it's automatically changing the state of the data. But what we actually got was it just kept going on and on and on because we didn't add the stop token when we trained. So there's these like quirks that you need to know when you start training. Another one is in this text to SQL example, the top part is the instruction. Immediately there's some extra instruction here. The input starts right here. The response starts right here. It's not structured, right? So why don't you just add new lines and see if that helps your model, right? So because the new lines can now be used as extra indicators of this is a context switch between the models. And so loss curve, one interesting thing to see is the loss curve fits really well, but then the predicted values are not actually SQL queries. So you wouldn't know by looking at loss curves that the model is not actually learning. But at least when we switched it to ones with the new line characters and the stop tokens, we could see better SQL queries generated from the LLM. Which brings me to the next point, which is lower loss and higher metrics. That's what you want, right? So loss can go sideways, but your metrics can actually improve. So this is a text classification task. It was like taking a bazooka to a knife fight, but we wanted to see if existing multi-class classification can happen with LLMs. And so turns out it can. But so we structured the output multi-label classification as a JSON output. Here you can see that this is the input, this is the classes. We don't have to go through what it was. Just see that the JSON schema kind of sort of matches. But then while the loss was going sideways, you could see the metric actually improve. So don't just look at the loss, and obviously you should look at the loss, but don't just look at that. Look at your metric and make sure that it is improving. And obviously your metric should track your KPIs for your business, because that's where the money comes from, right? Improve towards a target UX. So going back, what we did was we structured our LLM input as a very well-defined schema for what the task is. Here it is the identity. Here is the data format, like the question, the choices, and the answer. We also gave it tests, which is like, hey, when you generate the output, these are the tests that it must pass. So we're kind of like telling it how it will be graded, right? And then the output that is generated is action. It says, this is what I want to do. This is my step, and it changes the answer, right? So that leads us to this nice UX we saw earlier, wherein the LLM changed a value of the data. It didn't do a chat response. It changed a value in the data, and a React app changed the state of the UI. And then last one for the lessons learned is research if fine-tuning is right for you before you jump into fine-tuning, and then scale only when you're ready. Prompts still go a long way. You might not need fine-tuning. In fact, if I'm consulting somebody, they come to me and say, like, look, this is the data we want to fine-tune. I'm like, hold on. Do prompts really work? What are the challenges? So I still do have 6 minutes. I do want to give time for questions, but I wanted to show you like how I'm thinking about fine-tuning right now and why I am doing fine-tuning for the work that I'm doing. So AI Hero, which is what I'm working on right now, helps you automate your knowledge workflows. What is knowledge workflows? If you have, for example, a PDF file and you want to do step-by-step analysis on it, that analysis is a workflow. It's a knowledge workflow. And you want to do it every time you have a similar PDF. So if you're analyzing stocks, you have a PDF, a 10K filing, you will analyze it. A new release comes out, you will change the name, the file, and do the same analysis again, right? That's a knowledge workflow. That's what we're trying to automate. And so we've created this user interface, which looks like a Notion document, but it actually runs like a workflow. And so it represents your jobs to be done, connects with external data sources, captures your logic step by step, but you can also put in instructions here to generate the content out, right? And the reason why I think about autonomous agents slightly differently than the rest of the vendors out there right now is these agents need to run when you're not in front of your laptop, right? So it's running in the cloud. So you need to give it privileges. You need to be able to share the output with your team and so on. So that's the kind of experience we are creating. And this is just one of my paid users' data from last week, which is if you notice on the y-axis what the cost of 1 day of usage for this particular user is, it's in the hundreds, right? And so what happens here is the way in which LLMs work for, they're trained for chat interfaces, they're not trained for workflows. And so essentially that's one of those limitations why I feel I need to fine tune. The second one is we have this awesome scalable architecture that we've built out. There's a backend service called Autonomous, which gets when you click a play on the UI, it spins up a pod, that pod runs the workflow and does the magic autonomous agent work for you, right? And I'll explain that here. So this is just a simple workflow. I've clicked a play button here, which is what is 2 + 2. On the right-hand side, you could see like almost instantly within the second, the container created and it ran. The total time it took, though, was 12 seconds. Now, obviously, if you were doing this yourself, it wouldn't take 12 seconds. But because this is an autonomous workflow, that 12 seconds is too expensive for me. And so I want to reduce that time, right? So the prompt is very fat. I want to reduce the prompt, which will make the model faster. And then another one is this, the way we create automated plans. So instead of providing templates, we've just created a small little search bar where you can type what is the task you want. and it generates the workflow for you. First, it takes like 6 to 7 seconds on Turbo to generate it. If you have a robust model, it'll take 20 seconds, which is very, very painful to watch this thinking step. So we want to make that faster, right? And the second thing is, if I really had this problem, the workflow will show up for a split second, but you'll realize that in real life, you wouldn't use that workflow if that's your job, right? As a person who doesn't have this job, I think this workflow is good, but the person who's actually doing the job will be like, hey, this workflow just doesn't work. So we want to be able to fine tune to create these plans that work really, really well for everybody. And so that's kind of like why I'm training it, and brings us to the conclusion, which is think about fine tuning when it's clear that that's what you really need. Don't jump right into it. From a learning perspective, go to town, right? Start with QLoRA, figure out beg, borrow, steal GPUs, get your models trained to learn. But then at the end of the day, there's a simple equation here, which is the amount of money the customer is paying should be greater than the costs of the people, the data, and the on-demand compute. If it doesn't, then you shouldn't really get into fine tuning. That's my short little talk. Well, half an hour long talk. We have time for 2 more questions. 2 minutes for a question. And so if you are building automated workflows, exploring it, I'd love to compare notes. Let's chat after I'm here. Would love to learn your learnings about these. I was talking to Jacob earlier, and he's got some awesome learnings that I definitely want to catch up with him after this meetup.
All right, quick questions while we change podium.
I'd like to ask, so say you mentioned about the customer, their demands being like the first priority. Say if my task is to make sure that the output of the LLM constrains it to a specific structure such that the output can be directly implemented into a system. How relevant do you think fine-tuning would be in that scenario? Would an agent-based approach be better, or like multi-agent-based approach be better, or is for as far as an enterprise goes, how relevant would fine-tuning be?
Yeah, so from an enterprise perspective, what you're seeing in general agent terminology is that, well, I should speak with the mic. So what you see in the general agent terminology is people are using agents to generate code and then execute that code, right? You go to an enterprise that's, let's say, a Fortune 500 company and say, hey, I want to run a code that is automatically generated in your private cloud with all the private data. They'd be like, sorry, right? So what we are using fine tuning for is when the plan is generated or when the actions are generated, we want to be able to create some intermediate language which captures the instructions for the downstream actions, right? So we are not generating code and executing code, but we are generating some intermediate step of JSON so that can be executed by some code. So that guarantees us that the code that we're going to be generating, well, not code, the code that we will eventually be running is very structured, is guardrailed, and we know exactly what data it is using. The second thing we do is not related with LLMs at all, is the functions that are being called are based on RBAC. So you use OAuth to get the credentials from the user, and then the code that executes, make sure it has that OAuth key, so it cannot do chaos with somebody else's account. So that kind of enterprise grade stuff needs that kind of thinking. Not necessarily like, hey, can I fine tune the model faster, better?
Is value in fine-tuning such that, at least from a baseline, the parsing, the compilation of whatever the data is generated to passing the system is better.
I think we should generate code. The question was whether should the enterprises run it, and I don't think that we're there yet. Yeah, so I don't think that we're ready there yet. I wouldn't say no. I will say not yet. Yes.
My question is, that I don't understand, you have 16K, so you have data, like all of that, and how we decide your partner.
Okay, so that number stuck, which maybe next time I should not lead with that. So there was a project that I worked on. For that, we created a cluster for 16K GPUs, not now. So for this work, we are not training it on that many GPUs. Essentially, I took a step back after the fine tuning of these lessons learned. The first, I took a step back, like who's actually going to use it, right? And so I also talked to vendors about, hey, can I get GPUs? Can I get H100s, A100s? The way the costing works is this: you don't go to AWS and turn on a GPU and you start training. You do a contract with them, and they will tell you, well, you need to buy, even if you're doing A100s, you need to buy a $3 GPU. You need to buy 8 of them. You need to buy it for at least 1 year. So that's about like $12,000-ish per month. And so if your cost structure works, that, hey, I have enough data to train, the GPUs are not going to be idle, get that GPU cloud. I think personally, most of the time, we have data, but when we reach a threshold, we are like, we need to go change the data. So those GPUs would have been sitting idle. So instead we use a framework which allows us to compute only for 1 GPU, and then we don't pay for the GPUs not used. So you optimize on like what cloud vendor you use, not necessarily on getting more data.